Once we set up our pseudocode, now we're ready to translate our pseudocode into the C programming language and run that through Visual Studio. So let's go ahead and open up Visual Studio. We're going to hit Create New Project. Then it's Empty Project, Start from Scratch. Then we'll go with Next. This is the folder that Visual Studio creates on our desktop. Normally we would say Lab 2, Y, Sandoval, but since I'm going to post this after our notes, I'm going to call this one Energy. And actually I'm going to go ahead and give it a date, May 29th, Energy. Make sure we're not in the repository folder, because then I have to dig through to see where my program got saved. Make sure that this is on the desktop. We hit Create. There's our folder on the desktop being created. And then we want Project, Add New Item. We are not programming in C++, so we're going to change that to main.c. Click Add, and we're ready to program. Okay, so the next step would be to put in our required heading. We're going to put in the input-output library. We're going to suppress the scanf warnings. Define must come before include. Now what's new is, notice I also include the math library. And why I include the math library? Because of that v cubed. I'm going to want to use POW. Or actually I want to use POW. So I'm going to go ahead and include the math library, which is going to be new. Also that's new, I should move that so fast, is that 2.73. We're not in integer anymore. Now we need to work in double. Okay, so I'm going to include the math library. The math library has so many commands. We're using the POW command, for example. Okay, so we declare our variables. Variables are declared at the top of the program and not within the program. If you're going to declare variables within the program, then I'm going to go ahead and point them out and have you put them up top. Okay, so let's go ahead and declare our variables. Wrong, sorry about that. There we go, much better. Looking at our pseudocode, we're not going to need too many variables. We need a V to hold speed, and we need an energy, or EV. We need to hold energy. So those are the only two variables we need, and they're going to be decimal, so I'm going to use double. I'm going to call them speed and energy. Okay, then we look at line 1 of our pseudocode. Line 1 of our pseudocode is to read in speed. Okay, read is scanf. So we're going to say printf, enter speed. Got to give the user some directions. Then read in speed, that's our scanf. Now we're reading in a double, so we're going to say long float LF with the percent in front. Okay, so we're reading in a double into the address of the variable that I want to hold the input, and that's in that variable speed. Okay, next in our pseudocode is to calculate energy. Okay, so let's calculate energy, and I'm going to move this off to the side so we have our program formula in front of us. Energy is equal to 2.73 times. Now I could say speed times speed times speed, because that would be speed cubed. But because we included the math library, we have power available to us. It's speed that I want cubed. And so that's how I can get speed cubed. Okay, then we're going to take 10 divided by, be careful here to keep everything in the denominator. I want an extra set of parentheses around that speed minus 5 to keep it in the denominator, and then we hit enter. Okay, next is to print our solution. So I'm going to say printf. Okay, so then I'm going to give it a new line, \n, but I'm also going to tab over so it looks a little bit nicer when it prints out. \n is new line, \t is tab. New line and tab over, and then we'll say energy equals placeholder %LF. What do I want to put into the placeholder? I want to put into that placeholder the contents of energy. Okay, we're ready to test this out with a start without debugging, but how are we going to know our program calculates correctly? We'll know if our calculator calculates correctly if we have a test case. So my test case is going to be 9.1. So I'm going to take, just following the formula, 2.73 times 9.1 cubed times 10 over 9.1 minus 5. If we did things correctly, then we should see 5,000.68 for our decimal answer. Okay, let's see what we get. Start without debugging. There it is. Okay, so enter speed. I'm going to put in my test case, which is 9.1 and 5.017680073. Looks like our program is pretty good. Notice this tab over. So we tabbed over. That was our new \t. Okay, one thing else that I wanted to show you is maybe we don't need all these decimals. Let's just show 2 of them. So I'm going to say 0.2 right before the LF and right after the %. So right here in between, if I put a 0.1, I'm going to get 1 decimal. If I put a 0.2, I'm going to get 2 decimal. If I put a 0.3, I'm going to get 3 decimal answers. Let's see what it looks like with just 2 decimal answers. Okay, start without debugging. We'll put in our test case number 9.1. And we have 2 decimals instead of all the ones that were displayed before.